There's an experiment called quantum suicide. A scientist has you pull the trigger on yourself, but the gunfire is based on quantum states. If parallel universes exist, no matter how many times you pull the trigger, you won't die. Because across countless parallel universes, there's always one universe where the bullet doesn't fire, and your consciousness continues there. What does this mean? Subjectively, you never experience death. Even crazier, the 2022 Nobel Prize proved this with quantum entanglement. When Schrödinger proposed this theory, his opening line was, "What I'm about to say will make you think I'm crazy." But now it seems it wasn't him who was crazy, but the universe itself. Why is the universe so crazy? The answer begins one night in 1957. That year, a 27-year-old American, Hugh Everett, wrote a world-shaking theory in his Princeton dorm. He said the wave function never collapses. Every quantum measurement splits the entire universe in two. When he told his advisor fell silent for 10 minutes, because this implies that right now, as you read this, in countless other universes, countless versions of you are doing different things. But how does this work? First, we must discuss quantum mechanics, which drove Einstein crazy. In the early 20th century, as physicists studied the atomic world, they found a chilling fact. In the quantum world, everything is uncertain. Before observation, an electron can be in multiple places at once. This is quantum superposition. Stranger still, only when you observe it does it choose a definite position, like a spinning coin in air. Is both heads and tails. Only when it lands does it become one side. Schrödinger disliked this. In 1935, he devised his famous thought experiment, a cat in a box, with a device that may release poison based on a radioactive atom decaying. Before observation, the atom is decayed and not decayed in superposition. So the question is the cat dead or alive? Per the Copenhagen interpretation, until you open the box and observe, the cat is both dead and alive. Schrödinger meant this absurd example to mock mainstream quantum interpretations, but he accidentally touched a deep cosmic truth. Einstein strongly opposed it, famously saying, "God does not play dice." He believed the world must be definite, not this fuzzy superposition. But experiments repeatedly proved Einstein wrong. Quantum mechanics seems crazy, yet its predictions are terrifyingly accurate. Errors are negligible. Without quantum mechanics, no computers, phones, GPS, even the screen you're watching this on, relies on its principles. So if it's so effective, why do scientists still debate? It leaves a huge mystery. Why does observation collapse the wave function? What is observation? What role does consciousness play? These questions plagued physicists for decades, until Everett proposed his many-worlds interpretation. Everett said, "There's no such thing as wave function collapse. When you observe that cat, the universe doesn't choose life or death for it. Instead, it splits into two universes. In one universe, the cat is alive. In the other, it's dead. Your consciousness splits too. In one universe, you see a live cat. In the other, you see a dead cat." Sounds crazy, right? But this theory solves quantum mechanics' most vexing problem. It needs no mysterious observer effect, no special role for consciousness. The wave function just evolves smoothly via Schrödinger's equation. Whenever a particle faces multiple possibilities, the universe splits. All possibilities play out in different branch universes. Imagine, every second, trillions of atoms in your body make quantum choices. Each choice could split the universe. How many parallel universes does the cosmos split into each second? Infinitely many. But then, if the universe splits endlessly, why don't we ever feel it? Why do we see definite outcomes, not fuzzy superpositions? In the 1970s, physicists found the answer. It's called decoherence. Simply put, when a quantum system interacts with its environment, the different possibilities get locked into their own branches. They can no longer interfere with each other, like parallel lines that never meet. This explains why, living in a quantum world, we never see those weird quantum superposition effects. The 2022 Nobel Prize in Physics gave strong support to the many-worlds view. French scientist Alain Aspect, American John Clauser, and Austrian Anton Zeilinger experimentally confirmed quantum entanglement and proved Bell's inequality is violated. What does this mean? It means Einstein was wrong. The universe does roll dice, and in ways wilder than we imagined. Entanglement shows particles instantly affect each other, no matter how far apart. This spooky action at a distance is exactly what many-worlds predicts. More astonishingly, quantum computers are near proof of parallel universes. Classical computers use zeros and ones. Quantum computers use superposition. letting a qubit be both 0 and 1 at once. With 300 qubits, they perform 2 to the power of 300 calculations simultaneously. How big is that number? Far greater than all atoms in the known universe. Oxford physicist David Deutsch states bluntly, where are these calculations performed? If not in parallel universes, then where? So how many parallel universes are there? The answer might shock you. Infinitely many. And each holds a copy of you. Right now. In some universe, you didn't click this video. In another, you're landing on Mars. In a third, you're a billionaire. In yet another, you don't exist at all. Because your parents never met. Every tiny quantum event creates new branch universes. This cosmic tree branches more vastly than we can fathom. But the story isn't over. In 2017, scientists at Oak Ridge National Laboratory are conducting an experiment that seems boring. They bombard a wall with a powerful neutron beam. According to physics laws, no neutrons should pass through this wall. But strangely, they found a strange difference in neutron lifetimes. In particle accelerators, neutrons live an average of 14 minutes 48 seconds. But in lab bottles, they decay 10 seconds earlier. This 10-second difference cannot be explained by current physics theories, unless some neutrons travel to a parallel universe. Scientists propose a crazier theory, mirror universe. They think there might be a universe almost identical to ours, a mirror world, with mirror atoms, mirror molecules, even mirror Earth and mirror humans. This mirror universe is right beside us, separated by an incredibly small distance, perhaps only 1/1,000,000th of a centimeter. And neutrons, as special particles, might jump between the two universes. If this theory is true, then Oak Ridge scientists may have unintentionally opened the first door to a parallel universe. More interesting is the dark matter mystery. We all know there's much invisible matter in the universe. It doesn't emit light, doesn't reflect light, but makes up 85% of the universe's total matter. Scientists searched for decades but couldn't find what dark matter is. Now one theory suggests dark matter may not be in our universe at all. It might come from the mirror universe. Mirror universe matter affects our universe's stars through gravity. This explains why we feel dark matter's presence, but can never observe it directly. If this theory is correct, then our universe is like a sheet of paper, and the mirror universe is another sheet, the two sheets almost touching, but never overlapping. Speaking of this, we must return to the quantum suicide experiment. If the many worlds interpretation is true, then theoretically, you never experience your own death. Because in every universe branch where you die, your consciousness vanishes, and your subjective experience continues only. In branches where you survive, no matter how small the probability, there's always a branch universe where you survive. This is called quantum immortality. But no, this is only your subjective experience. In all other branch universes, your family and friends truly experience your death, grieve for you. So please never do this experiment. Everett himself was reportedly a firm believer in quantum immortality, though he never explicitly wrote this in papers. But his family and colleagues recalled that Everett believed his many worlds theory gave him a form of immortality. Ironically, in 1982, Everett died of a heart attack at age 51. But according to his own theory, in some parallel universes, he is still alive, perhaps continuing quantum mechanics research. This is a sad and thought-provoking ending. For someone who spent his life studying parallel universes, finally became part of parallel universes. Parallel universe theory also solves a problem that plagued sci-fi fans for years, the grandfather paradox. Suppose you go back in time, prevent your grandparents from meeting, then your father wouldn't be born, and you wouldn't exist. But if you don't exist, who went back to prevent your grandparents meeting? This is a dead loop. But if the parallel universe theory is right, this paradox vanishes. When you travel back in time, you actually enter a parallel universe. In that universe, changing history doesn't affect your original one. You're still born and grow up in your home universe. Then invent the time machine. So time travel is possible. But you're not changing your own past. You're creating a new parallel universe. Think about every choice you face now. Brush teeth or wash face first after waking. What to eat for lunch. Text that person you like. Each choice creates a new universe branch. In one universe, you confessed your feelings, and you're together. In another, you stayed silent and missed your chance. In a third, you met in a completely different way. Countless parallel universes, countless versions of you, each living a different life. Some versions succeed, some fail, some are happy, some suffer. But each one is equally real. What does this mean? Every decision you regret? In some parallel universe, another you made the right choice. Opportunities you missed. In another universe, you seized them. That person you longed for. In some universe, you're together. This truth is both harsh and comforting. All our regrets are resolved in some parallel universe, but also our successes elsewhere might be failures. This shouldn't lead us to nihilism. Quite the opposite. Parallel universe theory shows every moment matters immensely. Your choice right now creates a whole new universe branch, a unique universe just for you. In this universe, you are the sole protagonist. While countless parallel yous may exist, the you standing here making this choice is unique across the entire multiverse. Parallel universe theory remains just a theory. No direct experimental proof confirms it yet, but growing evidence points that way. Our universe might be one of countless others. Perhaps one day in the future, humans will invent advanced observation tech, truly opening the door to parallel universes. Then, we might see, in another universe, another you looking back at us, wearing the same look of surprise. And now, as you put down your phone and look up, the universe splits again. In one branch, you decide to follow this account, keep learning. In another branch, you swipe away this video. But in this universe, you now know the craziest truth about parallel universes. Remember, across countless parallel universes, only this version of you watched this entire video.